Hello everyone, so in this video we're going to be going through some calculus concepts, the basic calculus concepts that are required for advanced courses in statistics. Okay, so this video is by no means a very thorough and complete review of all the calculus concepts that one requires to be able to understand advanced statistics, or to be able to compute some like the PDF, some concepts in advanced statistics. But I would say these are the basic concepts that we need to understand, we need to know in calculus to actually study or to actually take a statistics, an advanced statistics course in college. Okay, so I actually recorded this video before, but I just realized that my voice was recorded. So I've already solved a few questions here, so let's just go through the questions again. So the first question is on limits. Okay, so if you're given this kind of limit problem, our first impression is that it's a series. Okay, it's a series. It looks complicated. It's definitely not direct substitution, right? So because if you directly substitute it with n goes to infinity, we have a bunch of n's here, so we don't know what it's going to be. So a trick is that we can manipulate this algebraically. So we can first rewrite this as, oh, okay, I realize that the numerators are factors of 2. So I can take 2 out, factor 2 out. And then I can factor n squared out 2 over here. And what's left here is something that we're familiar with, which is n plus 1 plus 2 plus 3 all the way up to n. We can rewrite it using this formula, n times n plus 1 over 2. I've already made a video about this, where this formula comes from, so you can check that out. So the limit as n goes to infinity of 2 over n squared, which is this, and then I'm going to just rewrite this one as this, n times n plus 1 over 2, and then you cancel things out, and we're left with this. And then I can split them into two fractions, into these, the sum of two fractions, and I get 1 plus 1 over n. And as n tends to infinity, 1 over n tends to 0, right? Any constant over something that tends to infinity tends to 0, because infinity is so big that the number just gets so small that they tend to 0. That it tends to 0. Now what's left here is 1, right? 1 plus 0 is just 1. So that's our answer for the first number. The second number is, we need to derive this equation or formula using the property of Euler's number E. Now we know this property, that the limit as t goes to 0 of 1 plus t to the power of 1 over t equals to E, Euler's number. Now, the only difference between this form and this form is that the inside, instead of 1 plus t, we have minus lambda over n here. So we let t to be equal to minus lambda over n. And as t tends to 0, n tends to infinity, right? Or vice versa. So I put this symbol right there. If and only if. I believe it is... they are like this, I believe so, because you can go any way based on this equation. So n goes to infinity, and in that case I can rewrite this limit as the limit as n goes to infinity. And in the place of plus t, we can write it as minus lambda over n. And what's 1 over t here is just a reciprocal of this, which is minus n over lambda. and then equals to e. Okay, so we're almost there in this step here. We're only left with one single step, which is to take both sides to the power of minus lambda to get to this form right here, which is the limit as n goes to infinity of 1 minus lambda over n to the power of n is equals to e to the power of minus lambda, which is the same form as this one. Okay, now the next question is differentiation. Now, if we're given this kind of function, now it looks very hairy. It looks kind of strange because you have a bunch of natural logs here. So if we were to differentiate this kind of function directly, that's a headache. I don't know how to differentiate this directly. I don't know how to differentiate x to the power of ln x, even though I can use the chain rule so many times, but I don't know how to differentiate this. So, but then a trick is that, well, we can, manipulate it algebraically. So how do we do it? Remember the properties of natural logs, or logarithms in general. So I can take this, the power down. And if I take the power ln x down, what's left? Ln x. So I can rewrite the inside of the, this of the brackets here as ln x times ln x. And remember the property, one of the properties of logarithms is that we can rewrite it as the summation, because the product of a times b can be rewritten as this, as a summation of the log of both a and b. Okay, so log of this plus log of that. And then seeing this form, this form looks definitely way less complicated than this form. So we can directly differentiate them, these two terms, okay? So differentiating these two terms, we got, well, what's the derivative of ln of x? It's just 1 over x. So we get 1 over the thing inside, right here, 1 over ln x, times the derivative of the inside. Remember, chain rule? The derivative of ln x is 1 over x, which is this one. And then this term is exactly the same as this term, so we have the exact same derivative. And then you simplify them, and we get 2 over x times ln x.